The last couple of weeks, what we did, we first did objects, and then we went into some of the other concepts that we need to lay the foundations of physics. Okay, and one of them, the first one after object, is distance. Okay, so here we have distance, the foundation of physics. It includes, that you need an object, but now you need also distance, and that's related to space. It's the separation between two objects. That's the qualitative notion of what distance is. Okay, it's not what it is in mathematics. In mathematics, distance is distance traveled. It's a movie. Distance here is a photograph. It's separation. Okay, separation is a static concept. Distance traveled, that's not a static concept. You need several frames of the movie to understand distance traveled, because you're unrolling the tip of the measuring tape. Okay, and here it is. Okay, this is the definition they have for distance in the religion of mathematics, mathematical physics. Here it is. This is out of Wikipedia. Distance is what? A numerical measurement of how far apart something is, right? Points are, or whatever. Yeah, what they're doing is they're unrolling the measuring tape. And then here in physics, distance may refer to what? A length. They're saying that length is distance. And we have a problem there, because there you see it at the bottom. Distance is what's between objects. It's the space between objects. You're unrolling the measuring tape from surface to surface of two objects, but you're unrolling the measuring tape through space, through nothingness, right? So distance is what separates two objects. Or like I like to say, distance is what lies between lengths. What is length? Length is the continuous matter of an object from surface to surface. That's what length is. Distance is not, the separation, the continuous matter between the surfaces of an object. No, it's the separation between two objects. Okay, so we have a difference between distance and distance traveled. And so, in order to show or to explain these concepts, I had to invent what I call this tool, the universal movie. Here it is. Okay, the universal movie is every atom in the universe in a single frame. Okay, if you want to see motion, you need, or any of the dynamic concept that you see at the bottom, you need to have at least two frames of the movie. Whereas for the upper ones, the ones in yellow there, they fit in a single frame because they're static concepts, and you do not need to have two frames of the movie to understand them. They're defined as static concepts. The ones at the bottom are all defined as dynamic concepts. You need two frames of the movie. And so here we have good old Father Universe. That's what he looks like. Okay. What is Father Universe? It's every atom in the universe, and it only has what you see at the top: distance, location, and existence. That's all it has. Okay. Every atom in the universe just has location, distance from all others. And that's what Father Universe is. Okay. Do the other frames bother you? Okay, let's put them in a single frame. There you see it. So that's Father Universe. Single frame. We don't need many frames to conceptualize Father Universe. Father Universe is just every atom in the universe that comprises the universe. Okay. And so what these people have is distance traveled. They don't have distance. What they have is they need, for distance traveled, they need two frames of the movie at least. Whereas for distance, all you need is separation. You can conceptualize distance in a single frame. Okay, so distance traveled is not the same thing as distance. Distance belongs to physics, qualitative separation. And distance traveled, which is a quantitative concept, belongs to math. It's an itinerary, a trajectory. Okay, so let's distinguish between those. Okay, and then we moved on to what we call location. Okay, here it is. Foundations of physics. Location, what is it? The set of distances from one atom to all others in the universe. Okay. Here we have it in the universal movie. Okay. Here you have good old God, and he's got distance separation, right? With respect to a cube, the earth, a cylinder, whatever. Every atom in the universe, if you will, right? So all we have is distance, separation. Okay. Here we have it in a single frame. If God wants to, be in a, we don't need a movie to conceptualize distance of God or every atom of God with respect to every atom in the universe. And we don't need that. And here we have good old God. If you want him to exist, he simply has to have location. And there he is. The definition here, physical presence. That's what it is. An object that has location. You get rid of this one. And all you have is existence. If you want to exist, all you have to have is a body, a thing, something that has shape, right? That which has shape. And it has to, in addition, have location. Okay? And so here we have good old God. If God wants to exist, it's very simple for him. All he's got to do is have distance, shown by all those lines, with respect to every atom in the universe. So what you're saying when you say, let us assume that God exists, what you're saying is, let us assume God is a physical object, an object, right? And God has distance with respect to every atom in the universe. That's what you mean by exist. That's what you're saying when you say that God exists. And when you say God doesn't exist, you're saying that God is either a concept or that God does not have location within the universe, meaning distance with respect to every atom in the universe. Okay, so we can talk about the existence of God or the non-existence of God in a rational way. We just have to define what we mean by exist. Exist is an object that has location. We're done, period. Punto final. Okay, so what is motion? I mean, we've got object, we have distance, location, existence, right? What is motion? The first dynamic concept that we're going to analyze, okay? Does Father Universe move? Well, Father Universe looks at himself and every atom just is there. That's it. It doesn't move. It just there, has location. He looks at himself, then goes to sleep for 1 billion years or 1 trillion years for an eternity. Then he wakes up and he looks at himself again. He says, all I have is location. Because he doesn't have memory. He doesn't remember his previous location. We humans, we living entities, we remember previous location. We have this thing in this recording device in our heads, and we record the previous location, the previous one. We say, oh, it's moved. But see, Father Universe only has, every atom only has location. Looks at himself and says, I only have location. Okay? And so what is motion? So let's go with the gurus. Let's go to good old Newton. He's the first guy who, I guess, or one of the first guys to attempt to define motion, right, scientifically. And he said, I do not define motion as being well known to all. Okay, so he came up with the 3 laws of motion. And he says, the first thing I'm going to do is not define motion. Okay, so that explains why you came up with the 3 laws. In fact, he did not come up with the 3 laws. The laws already, so-called laws, already were put out by people like Descartes and Galileo. They already had the same laws that Newton talked about. He just put them in 3 nice little phrases and they gave him the credit. But, these laws already were known and they were put on paper also. Okay? Look up the Wikipedia says, what is motion? And I love the fact that, they said the action or process. So they're already using words that are dynamic, that embody dynamism. They have dynamic embodiment in them, like action and process, and moving, changing, and movement, even position, because position in mathematics, right? In the religion of mathematics, what is position? It's how you get to the treasure chest, not where it's at. You have this these ordered pairs or ordered triplets, and what they are itineraries. How many steps to the right, how many steps north to reach the treasure chest. So position is not a static concept, it's a dynamic concept represented by an ordered pair or triplet or whatever. And it says motion is when an object changes. The word change, look up change, it involves motion. Position, again, an itinerary. Given time is built of motion. You need to define motion before you define time. They're using time to define motion. So we have all these contradictions, all these irrationalities. Okay, and yeah, Newton did not do a good job, so I don't think we can credit him with having defined motion or the three laws of motion, because he never knew what motion was. He never defined it. He specifically said, I'm not going to define motion because we all know what that is. What's the purpose of that, right? Okay, so you look it up in the dictionary. What is motion according to the dictionary today, right? And it says, motion, the action or process of moving or being moved. Oh, great. So motion is moving or being moved. Oh, we learned a lot. Motion is moved and moving. And you look it up in Merriam-Webster, says motion, an act. What's act and action? What is an action? Motion. Or instance of what? Changing. What is changing? Again, motion, movement. And so we have a problem because they're using synonyms or words that are founded upon motion to define motion. All these are irrational definitions. In fact, my recommendation is never look up a word in the dictionary if you're going to use it in science. Okay? That's the way it is. And then you have the definitions of action, of process, of moving, of movement, of change, and they all involve one of the others. So all they have is synonyms. They never define what motion is. What is action? A process. What is process? An action. What is moving? Movement, or capable of motion. What is motion? It's the word we're trying to define. What is change? Making something different from a different place or whatever. So all these words involve motion. You can't use any of those words to define motion. If you do, you don't have a definition of motion. What you have is a synonym, and synonym is a circular definition. No definition at all. Okay? Can't use synonyms or antonyms for that matter. Okay. Okay, so here we have the bot. We asked the bot, look it up, and we have all these R2D2s that they've created. Again, all this comes from mathematical physics, so keep that in mind. You won't find an objective answer. You'll find a subjective answer of mathematical physics. So if you look up the word motion, this is what you'll find. It says motion is when an object changes, right? And it talks about time. That was from Wikipedia. Look up change, you look up time, and it turns out they involve motion. Okay? You go to the Eric Weinstein, the Wolfram World of Physics, they have no definition of the word motion. They already start with types of motion. And the same thing for Stanford Encyclopedia of Philosophy. If they send you to a philosopher and say, hey, go find out from the philosophers what you mean by motion, they have no definition either for the word motion. And hyperphysics, one prominent site of physics, right? They also go into different types of motion, and they just say motion is described in terms of displacement, time, velocity, and acceleration. So they already have things in motion to define motion. Okay? Displacement is motion, time is motion, velocity is motion, acceleration is motion. So they haven't defined the word motion. And the bot, he tells you right in your face. It's the change in position of an object over time. What is change? What is time? Well, we already covered that. It's motion. So we have no idea what motion is from any of these people. No one in mathematical physics knows what motion is, can tell you what motion is. And just in case, people say, well, maybe some philosopher did that in the past. And we go to Ayn Rand, and she tells us what motion is, perfectly defined. Says motion presupposes the thing which moves. I love that. Without the concept of entity, there can be no such concept as motion. So she's saying in the first two lines there that for motion you need an object. Okay, great. Then she said change exists. No, change does not exist. Change is a concept, so change cannot exist, meaning she had no idea what the word exist means because she applied it to a concept. When a thing is changing, that is what it is doing. What is still is still. What is in process is in process. Oh, great. Then she says, but a moving object is not at any one place. If it is moving, it is not at a fixed position. That sounds a lot like Heisenberg's uncertainty principle. Principle of indeterminacy said, when the ball moves, it doesn't stand still. When it stands still, it doesn't move. That's what he got his Nobel Prize for proving that ball that stands still doesn't move. Great. And so, these people had no idea what motion is. And some people might criticize me and say, Bill, why are you making fun of poor old Ain't Rand? Yeah, I make fun of her because a lot of people say, hey, you said the same thing as Ayn Rand or Wittgenstein or any of those, David Hume or Immanuel Kant, right? No, none of those people have said anything that I said. If you confuse me with them, you have no idea what I'm talking about. You still don't understand. Now, these people never defined the word object. They never defined the word distance. Therefore, they knew nothing about location, which is founded on the word distance. And if you don't have location, you cannot define the word existence, let alone the word motion. So these people had no idea what motion, existence, location, distance, or object are. We have totally different definitions of these words. We set the foundations of physics. That's what we're doing. So when people confuse me with Ayn Rand or the electric universe, which thinks that plasma is a physical object or that ether is a physical object or that electricity is a physical object, I have to clarify and make fun of them so that you realize that, no, we are not saying the same thing. You simply did not understand so far, okay? Okay, so here we have the foundations. What is motion? Foundations of physics. Motion is two locations of an object. You have to have at least two locations. Here it is in the Universal movie, okay? You look at an object, in this case, some kind of box, square, cube, whatever you want to put in there. And in the second frame, you see it in a different location. That's what motion is. That's how we define motion. Two locations requires two frames, okay? And so with this, you destroy at least special relativity, if not all of general relativity as well, all of relativity. You say, why, Bill? Well, because, see, these people talk about going to the past or going to the future. And people like the past more than the future. Some people talk about going to the future, but people like to go to the past because we're more familiar with the past, with our history. And we say, hey, I'd like to be in the days of the Vikings or the days of the Aztecs or whatever. And say, I'd love to travel. And they've made lots of movies of time travel. It's almost always to the past. Okay? In general terms, it's to the past, because we're more aware of that, right? And so they say, hey, can you travel to the past? Well, most mathematicians say not to the past, but you can to the future for whatever reason. We don't care, right? But that's what they say. But let's look at the traveling to the past, right? It doesn't change our argument whether you go to the future or the past, but people, again, love to go to the past more than they like to go to the future. The question is whether you can go and see Napoleon or, Julius Caesar or Alexander the Great. Can you be there with Alexander the Great and shake hands with him? And Father Universe, destroys that notion. Says, no, that's impossible. And why? Because he has no memory. See, he doesn't have a filing cabinet where you can go to the frame where all the atoms are still there, right? In the present tense, are still there, and you can land on that frame where the Earth was like it was, thousands of years ago, or millions of years ago, or billions of years ago, that you can land there and you find the same atoms that we have today in a different location. Okay, so time travel requires that Father Universe keep, that frame of the movie. And here you have Brian Greene, and he does give you an idea of what I'm talking about here. He uses time, right? He says they have all these time slices, and all you have to do is go to one of those slices. Like if Father Universe makes clones of himself, of every atom that he's made of, in every location. So it's not like he's moving, he's creating clones at a new location. That's what these people are saying. And here it is. Good old Brian Greene. Listen to him. Well, it's just to see it. Okay, here it is. You see all these time slices that make up space-time, right? And he's got all these slices. He's got to cut them into slices. He's going to show you that, you have all these slices, that the universe is made of this block universe, the whole block, the whole loaf of bread. Okay? So what's the issue? The issue is these people say that you can go to one of those slices. And for that, Father Universe would have to make a clone of each slice at new locations as you go along. Okay, so you don't have the atom at a new location at a different frame. What you have is the second frame is a clone of the first one, but every atom is just a little at a different spacing than it was before. That's all it is. So these people are saying with special relativity that you're creating new atoms. You're cloning every atom in the universe at every frame of the universal move. And that's obviously irrational. I mean, if you want to believe it, yeah, that's religion. But it's irrational as an explanation. Okay, so just want to make sure that you understand that this tool called the universal movie, Father Universe only has location. He does not have motion. Motion is what we see when we watch the movie of every atom moving, because we have this recording device called the mind, thought, consciousness, whatever you want to call it, right? Spirit, in our brain. So we record previous locations, and that stays in our memory, and we're recording all along, right? We're recording all along. We're recording the whole thing. We say, hey, that lion, it moved from here to there. Not according to Father Universe. Father Universe only looks, wakes up after gazillions of years, and says all the atoms of that lion are at a given location with respect to all others. There is no motion as far as Father Universe is concerned. But we entities who have recording devices in our brains, at least for a short time, right? And we remember all these locations. We say, oh, the lion moved. Okay? So keep that in mind when you're analyzing location and time, and motion and time as well, right? Yeah, there is no time as far as Father Universe is concerned. That destroys the religion of special relativity, which is founded upon time, upon the fact that if the speed of light is fixed, it's a constant. What varies is time, and they prove that with an equation. Okay, we don't do that in physics. In physics, we look at reality. What exists is a static concept because it's an object plus location.